Okay, so I hope the number of ATP generated during the oxidation of one molecule of fatty acid through beta oxidation. How did we calculate it? That is, when one molecule of palmitoyl CoA enters into one round of beta oxidation, one complete cycle of beta oxidation can yield around 129 ATPs. If we are calculating that one molecule of FADH2 oxidation can produce 2 molecules of ATP. If you are exactly taking the number of ATPs as 1.5 ATPs rather than 2 ATPs, then the number of ATPs will be falling down to 106 ATP. Okay, that is NADH oxidation can yield 2.5 ATPs and FADH2 oxidation can yield 1.5 ATPs. So that's why the two contrast number of ATPs we have seen in the last slide. Okay, so if you are taking FADH2 oxidation can yield 2 ATPs rather than 1.5 ATPs. Similarly, if one molecule of NADH plus H plus can yield around 3 ATPs rather than 2.5 ATPs, then we calculate as the 7 into 2 plus 7 into 3 plus 12 into 8. 12 means 12 ATPs which are produced from one molecule of acetyl-CoA when it enters into the citric acid cycle or TCA cycle. So how many 8 molecules of acetyl-CoA is yielded, and this 8 molecules of acetyl-CoA, all of them enters into the TCA cycle, and each acetyl-CoA can give rise to 12 molecules of ATP. So you're having 8 number of acetyl-CoA from one molecule of palmitoyl-CoA. So 12 into 8 plus 7 into 2 plus 7 into 3, all of which yield giving rise to 131 ATPs. But we have already borrowed 2 molecules of ATP during the activation phase of the fatty acid to give rise to fatty acyl-CoA. So subtracting 131 2 from 131, you will be getting a total of 129 ATPs. Okay, if you may calculate, you may study as depending on your comfort. If you are easy to learn that 2 ATPs and 3 ATPs rather than 1.5 and 2.5, it's okay, it's well and good, but you have to calculate it in the exact manner, right? So 129 ATPs will be formed if you're taking, or we are calculating as 2 ATPs from one molecule of FADH2. അതുപോലെ 3 ATPs from one molecule of NADH plus H plus. അതല്ല, if you're taking the exact amounts of ATP, then you get that rather than 129, you'll be getting only 106 number of ATPs. Both are correct. Okay, so it is up to you. You can decide whether you want to study it in the 2 or the 1.5 pattern. Okay, so the only thing is that you have to calculate it in the proper way. Okay, right. So next, so now we have understood that there's such a huge number of ATPs are obtained when one molecule of fat is getting oxidized, or when compared to that of a glucose. When a glucose molecule is undergoing complete oxidation, we get only 32 number of ATPs. So it is around 10 times, I mean, it's not, 10 times greater than that of 32 and 131. So that's such a drastic change happening in the case of oxidation of glucose. And if you're comparing the number of ATPs obtained from one molecule of glucose and one molecule of fatty acid, right? So if you are getting such a great amount of ATPs from fat, how can you regulate the fatty acid? If it is continuously going on oxidizing fatty acid, there will be a huge number of ATPs formed in the body, but there will be always a control over all the oxidative pathways and also the synthetic pathways. Okay, so that everything is kept in balance. So how is the fatty acid oxidation, beta oxidation of fatty acids, how is it regulated? How is it made under control? Because if you're not in need of energy, then there is no requirement of fatty acid oxidation, right? So but if you are in need of an increased demand of fatty acids, then immediately it should come and it should be ready for carrying out a beta oxidative pathway. So how is it regulated, or how do we come to know that fatty acid is ready to be beta oxidized or not? Which are the controlling factors? Are they controlled by enzymes, or are they controlled by hormones, etc.? Okay, so this video is regarding the regulation of beta oxidation. So there are mainly two enzymes. There are two enzymes which are controlling the fatty acid oxidation, right? So the fatty acid oxidation is controlled at various levels, right? There are two main enzymes which are responsible for activating the beta oxidation or inhibiting the beta oxidation. The body will not be subjecting fatty acid for oxidation under unnecessary conditions. Only when the necessity arises, then only the beta oxidation will be happening. So under the remaining time, the fatty acids will be remaining silent. Whenever the demand increases, then only the fatty acids are subjected for oxidation. So they are having a control, they are under regulation, or there is some inhibitory force acting on the enzymes, so that fatty acids are not unnecessarily subjected for oxidation. Because one fatty acid and oxidizer, you get 129 number of ATPs. Appa adane dharalamanu. Appa pinne എന്താ പറയുക, അനാവശ്യമായിട്ട് fatty acids will not be oxidized, because it is always stored in the body whenever there is energy purpose മാത്രമല്ല, there are fatty acids carry out or TG fat ഇതൊക്കെ cushion ആയിട്ട് act ചെയ്യും. Then fat soluble vitamins in the functions act ചെയ്യും. So there are numerous activities carried out by the fat. So it is, they are not unnecessarily utilized for the energy production. But whenever there is an energy demand, whenever the energy demand is not able to be met by the carbohydrates, then the fatty acid arises. Okay, so there are some inhibitory and activatory mechanisms happening on the fatty acid, beta oxidation of fatty acids. So which are the enzymes involved in the regulation of fatty acid oxidation? The first one we have already told, that is which is the rate limiting enzyme of the pathway. When we were talking about the various stages, the beta oxidation involves 3 different stages, right? Activation was there, transport was there, and also the beta oxidation. So when we were talking about the transport mechanism, the shuttle system, we have came across 3 enzymes like E1, E2, and there is a translocase enzyme, right? CAT1, CAT2, right? CAT1, which transports fatty acyl CoA from the outer side of the inner mitochondrial membrane to the intermembrane space, right? For the action of translocase enzyme. And there we have told that CAT1 is the rate limiting enzyme of beta oxidation. So which is the regulatory enzyme? One of the regulatory enzyme is the CAT1 or carnitine palmitoyl transferase 1, or we can call it as carnitine acyl CoA transferase 1, right? Or simply it is named as E1. So one of the regulatory enzymes which is responsible for carrying out the beta oxidation is the E1, or the regulatory enzyme or the rate limiting enzyme is CAT1 or E1 or CPT1 or carnitine palmitoyl transferase 1 or carnitine acyl CoA transferase, or everything is one and the same, right? So that is one of the regulatory enzyme. Now a second enzyme is also there, which is responsible for causing always an inhibitory effect on the fatty acid oxidation, that we called as acetyl CoA carboxylase enzyme. We haven't came across this enzyme so far. It is coming under the fatty acid synthetic pathway. നമ്മൾ ഇപ്പൊ പഠിക്കുന്നത് fatty acid oxidation ആണ്, catabolism ആണ്. Now whenever it is catabolized, it has to be replaced, no? So for the that is the concentration of fats has to be maintained always at a normal level. So whenever there is a depreciation, or when there is a deterioration, or whenever there is a decrease in the stored fat, what happens? The fat has to be restored, it has to be replaced. Fatty acid content കുറഞ്ഞു കഴിഞ്ഞാൽ, ഫാറ്റ് കണ്ടന്റ് കുറഞ്ഞ ഉടനെ ബോഡി എന്ത് ചെയ്യും? ഫാറ്റിനെ സിന്തസൈസ് ചെയ്യാൻ തുടങ്ങും, TG-നെ സിന്തസൈസ് ചെയ്യും, right? So there അല്ലെങ്കിൽ fatty acids നെ TG സിന്തസൈസ് ചെയ്യണമെങ്കിൽ we should have fatty acids, right? So fatty acids has to be synthesized by the body, and this synthesis of fatty acid is carried out by one of the major enzyme, which is known as acetyl CoA carboxylase. So the acetyl CoA carboxylase enzyme come under the synthetic pathway of fatty acids. Clear? So we know that always the synthesis and degradation, catabolism and anabolism are always in a balanced manner. It's happening in a balanced manner, right? So when we are discussing about the regulation of beta oxidation, there are 2 enzymes involved in the regulation. One is our CAT1 or E1. Another regulatory enzyme which always makes an inhibitory effect. ആവശ്യമില്ലാതെ ബീറ്റ ഓക്സിഡേഷൻ നടക്കാതിരിക്കാൻ വേണ്ടി ഓൾവേസ് അവർ എപ്പോഴും സപ്രസ് ചെയ്ത് വെക്കും, ഇൻഹിബിറ്റ് ചെയ്ത് വെക്കും, പ്രിവെന്റ് ചെയ്ത് വെക്കും. അങ്ങനെ ഇൻഹിബിറ്റ് ചെയ്ത് വെക്കുന്ന ഒരു എൻസൈം ആണ് ആര്? അസറ്റൈൽ കോയെ കാർബോക്സിലേസ്, വിച്ച് ഇസ് എ സിന്തറ്റിക് എൻസൈം. the fatty acid biosynthesis enzyme ആണ്. അപ്പൊ synthesis നടക്കുന്ന സമയത്ത് ഒരിക്കലും എന്ത് നടക്കില്ല, degradation നടക്കില്ല. That we have discussed when we were dealing with the carbohydrate metabolism. അല്ലെ, anabolism നടക്കുന്ന സമയത്ത് anabolism മാത്രമേ നടക്കുള്ളൂ, ഒരിക്കലും അവിടെ catabolism നടക്കില്ല. Catabolism അവിടെ reduce ചെയ്ത് വെച്ചിട്ട് അല്ലെങ്കിൽ suppress ചെയ്ത് വെച്ചിട്ടാണ് anabolism അവിടെ നടക്കുക. അതുപോലെ anabolism സ്റ്റോപ്പ് ചെയ്യേണ്ട സമയം, എനിക്കിപ്പോ catabolism ആണ് ആവശ്യം, എനർജി ആണ് ആവശ്യം എന്നുണ്ടെങ്കിൽ പിന്നെ അപ്പോൾ എന്ത് ചെയ്യും, anabolism will be inhibited and catabolism will be activated. Clear? So in the fatty acids also, whenever the beta oxidation is happening, there are two enzymes involved. One is that is we are going to activate the fatty acid oxidation, right? Above always under normal condition, always the fatty acids are the fatty acids degradation or beta oxidation of fatty acids will be remaining silent, and this silence is made by an enzyme known as acetyl CoA carboxylase. അയാളാണ് silent ആക്കി വെക്കുക ആരെ, ഈ CPT1 നെ അല്ലെങ്കിൽ CAT1 നെ അല്ലെങ്കിൽ E1 നെ. Clear? So the two enzymes involved. ഇനി അതല്ല എനിക്ക് ഓക്സിഡേഷൻ നടക്കണം എന്നുണ്ടെങ്കിൽ ഈ ഇൻഹിബിറ്ററി ഇഫക്റ്റിനെ റിമൂവ് ചെയ്യും, അതായത് അസറ്റൈൽ CoA carboxylase അങ്ങനെ മാറ്റിയിട്ടാണ് what happens, our CAT1 will be undergoing activation, then only the beta oxidation will be initiated. So that is how the regulation of fatty acids, regulation of beta oxidation of fatty acids are taking place. So there are two regulatory enzymes. One is the CPT1 or E1, and the other enzyme which is having a control over beta oxidation is the synthetic enzyme which is known as acetyl CoA carboxylase. What does acetyl CoA carboxylase do? Acetyl CoA carboxylase carries out the carbon dioxide, addition of carbon dioxide on acetyl CoA. Carboxylation of acetyl CoA na carry out. What happens when carbon dioxide is attached to acetyl CoA? It results in the formation of a compound known as malonyl CoA. When we were having a TCA cycle, we have discussed about it, right? So fates of pyruvate പറയുമ്പോൾ malonyl CoA യുടെ കാര്യമൊക്കെ പറഞ്ഞിട്ടുണ്ട്. So acetyl CoA can be converted into malonyl CoA by undergoing carbon dioxide carboxylation reaction, and this is carried out by the enzyme known as acetyl CoA carboxylase, and it is a synthetic enzyme. Clear? So these are the two enzymes involved in the regulation. The CAT1 always activates fatty acid beta oxidation, while acetyl CoA carboxylase always keep the beta oxidation in the suppressed manner. എനിക്ക് അവിടെ കാറ്റബോളിസം അല്ല, പകരം എനിക്ക് സിന്തസിസ് നടക്കണമെന്നുണ്ടെങ്കിൽ immediately the E1 will be or the CPT1 will be inhibited. This inhibition is made possible with the help of another enzyme known as acetyl CoA carboxylase. Clear? That is malonyl CoA. It is acting as the inhibitor. അപ്പോൾ malonyl CoA അവിടെ വരണം എന്നുണ്ടെങ്കിൽ what should happen? Acetyl CoA carboxylase should become active and it should cause the carboxylation of acetyl CoA so that malonyl CoA is formed. This malonyl CoA go and inhibits the CAT1, thereby blocking the further beta oxidation of fatty acids. Instead, what happens? Fatty acid synthesis will be taking place. Clear? So that is the allostric mechanism of beta oxidation. That is, the enzymes involved are the acetyl CoA carboxylase and the CPT1 or CAT1, right? So CAT1 is an allostric enzyme. So CAT1 is having an inhibitor, the modulator. Allostric modulator can be an allostric inhibitor, and the allostric inhibitor is the malonyl CoA, while the activator is the free fatty acid. Clear? Free fatty acid on the fatty acid CoA ആയിക്കഴിഞ്ഞാൽ CAT1 becomes active. അതേസമയം എനിക്ക് synthesis നടക്കണ്ടെന്നുണ്ടെങ്കിൽ ഉടനെ what happens? Acetyl CoA carboxylase comes, causes the carboxylation of acetyl CoA and brings about the formation of malonyl CoA. ഈ malonyl CoA നേരെ പോയിട്ട് ആരുടെ മേത്ത് പോയിരിക്കും? CAT1 ന്റെ മുകളിൽ പോയിരിക്കും. So that CAT1 will be inhibited. So this is one mechanism of regulation of beta oxidation by allosteric mechanism. See, we have already discussed that always the regulation of pathways can happen through two mechanisms, either by means of allostric or covalent mechanism, allostric mechanism, or by means of covalent modification. Covalent modification endandava phosphorylation, dephosphorylation reactions happens. That is, enzyme can exist in two conformations, a phosphorylated form and the dephosphorylated form. So if phosphorylation, dephosphorylation again എങ്ങനെയാണ് നടക്കുന്നത്? With the help of hormones. Hormones വരും, bind ചെയ്യും, cyclic AMP ഉണ്ടാവും. Cyclic AMP causes the activation of protein kinases. Protein kinases എന്ത് ചെയ്യും? It adds phosphate onto the corresponding enzyme, thereby converting the enzyme from its active form to the inactive form, or the inactive form to the active form. That is how the hormonal regulation happens. So the next mechanism of regulation of beta oxidation is the hormonal regulation. So there are two mechanisms with which beta oxidation can be regulated. One is the allostric modification, and the other one is covalent modification.